nucleophilic aromatic substitution reaction of pyridine. Apart from electrophilic aromatic substitution reaction, pyridine can also undergo nucleophilic aromatic substitution reaction, where a weakly basic group will be replaced by a strongly basic nucleophile. Normally, the nucleophilic aromatic substitution reaction in pyridine takes place at either at C2 position or at C4 position. Let's take a look at the mechanism. The nucleophile will add to the ring where the leaving group is present, thrust these electrons onto nitrogen. In the next step, these electrons that is present on nitrogen will be pushed back in to restore aromaticity, and the leaving group is going to leave. Now, if both of these groups right here are exactly the same basicity, then you will get both reactants and as well as the products. But let's say that if Z is going to be strongly basic compared to Y, then the reaction will not happen. This step would be normally fast. Now you can see that the nucleophile has been substituted for a weak base. Why the nucleophilic substitution reaction of pyridine happens at the second and fourth position and not at the third position? For that, we have to look into the resonance contributors of the intermediates that is obtained in the reaction. Say, for example, in the case of second position and as well as in fourth position, we are forming a more stable intermediate. Now, why should this be stable? So if you look into the other resonance contributors, you can see that the negative charge is on carbon. Right? When you want to put a negative charge, you have to try to put it on a more electronegative atom. Here, the negative charge is on nitrogen, which is more electronegative. And therefore, these resonance contributors are more stable. But in the case of third position, it doesn't form a more stable resonance contributor because in all of these cases, you can see it is the carbon which is having that negative charge. So it is comparatively less stable. Right? Because of this, the nucleophilic substitution reaction of pyridine happens at the second and the fourth position. Here are some examples for nucleophilic aromatic substitution reactions of pyridine. And here we do have two substituents, one at position 2 and the other one at position 4. Right? Between these two groups, obviously it will be Cl that will be replaced by the methoxide ion. Okay? The CH3 is strongly basic and therefore it will not even be replaced by a nucleophile. So the Cl will be replaced here to give the methoxy substituted pyridine. Now when you look at the next compound, we do have two groups. We have a methoxy group and we also have a bromine. Now between these two, whichever is weakly basic, that will be replaced by the nucleophile. So between these two, obviously it is bromine, which is it is a bromide ion which is weakly basic, and therefore this will be replaced by the incoming nucleophile. So you get the amino substituted pyridine here in this case.